So predict the structure of the product based on this information provided of the reactant and the reaction conditions. The formula is given. If you look at the formula, it has 10 carbons and 10 hydrogens. Don't worry about the hydrogens, but look at the carbons, right? If you count the number of carbons, that is 10 carbons, and somehow the molecule, upon treating it with acid and water, is losing that carbon, and it is also losing these 2 carbons in the molecule. And as you can see here, it is to be recognized as an acetal here, right? That's an acetal. And you know that anytime you have an acetal and treat it with water, which is going to be catalyzed by acid, you are going to get the corresponding carbonyl, and that carbonyl here is essentially your ketone. So the ketone here and the alcohol are going to now disassemble, and that's a product for the first treatment of the water to the molecule. And now if you look at that, the other side is still going to have your ester group, and acid and water is also going to hydrolyze the ester to the corresponding product, which is going to be carboxylic acid and alcohol. So this molecule is going to become now that. Okay, so that's the hydrolysis of an ester. You get the carboxylic acid and the alcohol. Now this molecule, as you can see here, it's a alpha beta keto carboxylic acid, and I'm sure you have seen this in your lecture, that anytime you have a beta keto carboxylic acid, it is going to undergo decarboxylation upon heating. So what happens is, upon heating, there is going to be a movement of electrons that looks like that, and you are going to get the enol here, right? And since that carbon-carbon bond is broken, you are going to get carbon dioxide, and that enol is going to tautomerize to the ketone back. So it's going to tautomerize to the ketone back, and that is the structure of the final product, which is 6, 7, 8, 9, 10. Oh, so C6H10O. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's the structure of the product. So the interesting part is that you should always remember, when you have a beta keto carboxylic acid or a beta carboxylic acid, it is going to undergo decarboxylation. You will lose one of the carbon dioxide molecules, and that carbon that holds onto that has the CO2 structure is going to get a hydrogen there. Okay, so that's essentially is what is going on.